Hello again, I'm Steve Eath here, coming to you today with a video to give you a quick update on a couple of additional changes that I've made to the breast cancer cell line knowledge base recently to try and explain why I've made some adjustments to the site and to show you a couple of new features that I think you might be interested in. So without any further ado, I'm going to go ahead and share my screen now and take you right to the changes to the website. Okay, so it occurred to me recently that most of the people who come to the website and who are using it really are coming to it because they have an interest in one or more of the some breast cancer cell lines. And that's great because that's what it was originally designed for. But as you may or may not know, over the last, I don't know, year or so, I decided to try and make this a more generally useful breast cancer cell line knowledge base for not only the some lines, but for about another 40 or 50 other breast cancer cell lines that are in common usage throughout the world. And so, one of the first changes that one of the changes I should say that I've just made recently to try and sort of give equal emphasis to the some lines and to the other breast cancer cell lines is basically just a reorganization of the banner on the homepage and that you see throughout the website. So if you recall, originally up here on the banner, I had a link to a page for each of the some breast cancer cell lines that one could just click on and go to. And so what I decided to do is to now just generate this gateway to the some breast cancer cell lines. And it just will take you to all of the same pages, but instead of listing all of the some lines individually at the top of the banner, we now have this gateway and you can now scroll down to any one of them. And of course, all of the submenus that are associated with each of the some lines appear. And so you can just go ahead and click directly on, in this case, Sum 159 Home, and this is the same page as it was before. Or you can use these menus to just go to one of the other sort of sub pages this way. So there's a couple different ways now to navigate to get to all of the information on all of the some breast cancer cell lines. And then the next set of pages are also associated with the some lines, and this is the page for the data mining tools for the some breast cancer cell lines. This isn't changed, this is the same as it's always been, but the order is just a little bit different so that you now have the some breast cancer cell line gateway and then the link to the page for the some breast cancer cell line data mining tools. Okay, so then to sort of make this a little bit more consistent then, now there's a second gateway, and this is the gateway to 40 other breast cancer cell lines. And as I sort of began to talk about in an earlier video, what I've now done is generated a page for each of these 40 breast cancer cell lines. And so you can get to those again in one of two ways. You can just click on the gateway to the 40 breast cancer cell lines, and they're all listed here. And if you watched the last video, you may recall that at that point I had just started putting in keywords for some of these cell lines here at the bottom. And so now what you can see is that for all of the breast cancer cell lines on this page, I've got keywords associated with all of them so that one can see very, very quickly the key features of each cell line, and you can decide whether to sort of delve into this more deeply. So for example, the EFM19 cell line is an ER positive, HER2 negative luminal cell line with a PIK3CA mutation and a P53 mutation. So that's a lot of really interesting information that comes in a single line. And so those sorts of keywords are present for each of these cell lines. So once again, now you can get to all of those cell lines either through this gateway page, or if you just mouse over this, you can now just scroll your way down and just pick out any of your favorite breast cancer cell lines and go directly to that page for that cell line. So now, just as a reminder for this part of the knowledge base, each of these breast cancer cell line pages has a little bit of a summary of what's going on with the cell line and links to Cellosaurus, to Cosmic, and to DepMap Portal, so that you can get to all kinds of other detailed information on any of these cell lines. And again, I sort of outlined that for you in the previous video, so I don't want to go into that again here. What I do want to do, however, and what I want to talk about here is one pretty significant change that I did make to these breast cancer cell line pages. Because in the original version of this, I had basically just put a table that indicated the drug sensitivities associated with each of those cell lines, and those came from the functional druggable signature tool. Now that functional druggable signature tool is still present for any of these breast cancer cell lines. But what I wanted to do is to make this a little bit richer and a little bit easier to make the connections between the gene essentiality and the oncogenes in any cell line, and how that associates with their sensitivity to specific targeted drugs. And so what you can read about here is what I've now done is I've generated a series of drug sensitivities for each cell line, which I refer to as tier 1, tier 2, and tier 3. So the tier 1 drugs are those that target some bona fide oncogene that is structurally altered in the cell line, and to which the cells are highly sensitive to the targeted drug, in this case with a z-score of -1.5 or lower. So this is the best candidate drugs. The cells have a functional oncogene, and the cells are also sensitive to a drug that targets that oncogene. So again, those are the best drug candidates. The tier 2 drugs, though, are those for which there is an association between essentiality of the gene, either in the CRISPR or the RNA screen, and sensitivity to the targeted drug, regardless of the genomic status of the gene. So the rationale for this approach is that if the gene is found to be essential in a cell line, and that cell line is sensitive to a drug that targets the same gene, we assume that that sensitivity is real and it represents a true on-target drug sensitivity. So that's, again, pretty straightforward, I think. Now, tier 3 is a little bit more interesting and a little more challenging to explain, because these are drugs that target a gene that was not a hit in the functional screen, but the cells are still highly sensitive to those targeted drugs. And to identify the most likely true target drug interactions and sensitivities as shown in tier 3 are those in which the cells exhibit a sensitivity to 2 or more drugs of the same target, which gives us confidence that that sensitivity is correct. Alternatively, if a single drug has multiple targets, 2 or more of which are expressed in the cells, and the cells are highly sensitive to that drug, then the presence of more than one target in the cells explains the disconnect between sensitivity and to the targeted drug and essentiality. I know that's a mouthful. I'm going to show you an example, some examples of that. But here's just, I think, one really good example. So, for example, there are a number of drugs that target all 3 isoforms of AKT, so AKT1, 2, and 3. Now, if the cells are expressing both AKT1 and AKT2, that would explain why knocking out one or the other in the screen didn't point to one of these genes as being essential. But if there's a drug that actually hits all the isoforms, the cells can still be very sensitive to that drug. And we would assume that that's an on-target sensitivity. That's correct. So I wanted to try and identify for each cell line the tier 1, tier 2, and tier 3 drug sensitivities. And so now what's new here and what you have in these pages are good examples of that. So let's start with this cell line at the top, AU565. This is a HER2 amplified, ER negative breast cancer cell line. The expression profile is the HER2 amplified breast cancer was derived from a pleural effusion. And so again, now if we click on the link for this cell line, you can see the oncogene signature, and this hasn't changed. And I explained all of this in the previous video, so you can take a peek at that if you haven't already. But now here's the part for the best druggable targets for this cell line, AU565. And so the tier 1 drugs, you won't be surprised, are the ones that target ERBB2, because ERBB2 is DNA amplified in this cell line. It's highly overexpressed, and the cells are actually quite sensitive to a number of different drugs that target ERBB2. So this is exactly what you might predict for an ERBB2 amplified cell line. The gene's essential in these cells because it's a bona fide oncogene, and the cells are sensitive to the targeted drug with really, really good z-scores, even less than 2, and sometimes even less than a -3. So highly sensitive to these targeted drugs. All right, well, what else might be going on in this cell line? So here's mTOR, AKT, ERBB3. these are genes where if you look at the Achilles score, the Demeter score, anything, as you recall, with a score here of less than -0.5 indicates the gene is essential in these cells. This is the cut point for genes that are considered to be hits in the screen. So in each case, mTOR, AKT, or B3, the genes were hits in the screen and the cells are quite sensitive to the targeted drugs. So these aren't oncogenes now. There's nothing going on with mutations or amplifications here, but there is a connection now between essentiality and drug sensitivity. So again, when that happens, we consider that to be a real thing. And so, and again, this is not at all surprising, right? Because ERB2 signals through the PI3 kinase pathway, mTOR is in that pathway, AKT is in that pathway. We know that ERB2 talks to ERB3. ERB3 was highly essential in these cells. So this drug that's sort of associated with ERB3, the cells are quite sensitive to that as well. So the tier 2 drugs make sense. And now you have a longer list of drugs to which these cells are sensitive in a way that makes mechanistic sense. And then now we've got these tier 3 drugs where we have a drug here, this MN64, which actually targets 2 different isoforms or 2 different tankerase genes. And the cells are quite sensitive, even though neither of these genes were hits in the screen. And the idea is if both isoforms or both genes are present in the cell, it won't hit as a screen, but if there's one drug that hits them both, then you can still have that kind of sensitivity. Let me show you sort of a better example of tier 3 drug sensitivity in a very, very interesting cell line, which I think will make this make even more sense. So DU4475 is a cell line that actually is a BRAF mutation. This is a breast cancer cell line. So we think that has a classic V600E point mutation. It has a really strong CRISPR score, so the gene is essential in these cells. So this is a bona fide oncogene that has a mutation and is highly essential. And not surprisingly, if you look at the tier 1 drugs, all of these 4 different BRAF targeted drugs, the cells have really, really strong Z-score. So these cells are highly sensitive to BRAF targeted drugs, just as you would expect for a cell line with a functional essential BRAF point mutation. And then again, with regard to tier 2 drugs, there's some really interesting associations. This is one of my favorite targets, BCL2L1. This is a drug that targets BCL2L1. This gene was a hit in the Achilles screen, a very strong hit, and the cells are very, very sensitive to the drug. So here, a good association between essentiality of the gene and sensitivity to the drug. So we believe that the sensitivity is correct and on target. And there are a number of these like this here, where there's that good association between sensitivity and essentiality. So some of those tier 2 drugs make good sense. But here's a great example of the tier 3 drugs. What you notice here is this PD drug here, 325901, targets both MAP2K1 and MAP2K2 with very good Z-scores in both sets of experiments that were done. But neither of these genes were essential in the screen. Well, how does one explain that? And so I've sort of shown this picture that's part of this page, where here's the MAPK signaling pathway. Here is BRAF, which is point mutated in these cells, and you can see that BRAF phosphorylates MEK1 and MEK2. MEK1, the gene names for MEK1 and MEK2 are MAP2K1 and MAP2K2, and this drug actually targets them both. And so given this signaling pathway, and this is a hit in the screen, these genes were all hits in the screen, so you can see this whole pathway is quite essential as a result of the mutation in BRAF, but these genes were not hits in the screen, and the reason is because they're both present. And so if you knocked out MEK1 in the screen, MEK2 still functions to phosphorylate ERK, and vice versa. But now, if you come along with a drug that actually inhibits both MEK1 and MEK2, you see that really, really high drug sensitivity. So this is the kind of thing that can explain the disconnect between drug sensitivity and essentiality in the screen. And that's really what we're trying to capture in all of these tier 3 drug sensitivities. And so, like I said, now this is now present for all of the breast cancer cell lines here in this gateway. And if you scroll through these and find your favorite cell line, you're going to see that, there are some cell lines where there's not a whole lot of drug sensitivity, and there are others where there are many, many choices of what we think are good bona fide drug sensitivity. So BT549 is a claudin low triple negative primary tumor derived cell line with a P53 and a P10 mutation. You might not expect there to be a lot of drug sensitivities associated with this cell line, and you'd be correct. So here's the oncogene signature with just P10 and P53 showing up. There are no tier 1 drugs, there are no tier 2 drugs, and there's only one drug that sort of meets the criteria for tier 3. And so, again, all of these different cell lines with all of their different biologies, really run the gamut with respect to drug sensitivity. Going back to EFM 19, this is an ER positive HER2 negative cell line with a PIK3CA mutation. So here the estrogen receptor is highly overexpressed. It's got a classic PIK3CA mutation among some other things. It's got a P53 mutation. And these cells have a number of interesting drug sensitivities. This is a SERD drug that targets the estrogen receptor. Not too surprising that the cells are sensitive. This gene is highly essential in this cell line. And of course, alpelisib, the PIK3CA targeted drug as well, good sensitivity associated with that mutation. But then again, some additional drugs where the cells exhibit some really high sensitivity, either in association with essentiality or disconnected from essentiality in ways that we still think those sensitivity data are correct. So this introduction of the tier 1, tier 2, and tier 3 drug sensitivities is all brand new to these 40 breast cancer cell lines. So I hope you'll take a look at that. And again, we have, just as we did before, the data mining tools that go along with those additional breast cancer cell lines, and those have been explained previously. But it's always fun to sort of use those tier 1, tier 2, and tier 3 drug signatures in combination with the use of the functional druggable signature tool, in which using this tool now you can basically see all the drug sensitivities for any of the cell lines. And these are just presented now, rank ordered by the Z-score and the GDSC2 analysis. So by going back and forth between these two tools, you can really know everything there is to know about the genomics of the cell line and all of the potential drug sensitivities. And and the idea is that this will make it easier to start thinking about how to do drug combinations if you can begin to think about using combinations of drugs to which the cells are highly sensitive, so one can use very, very low doses of those drugs. Okay, so that's this latest update. I'm going to actually come back in a minute with it, make another video and show you another aspect of this, but I want to sort of try and keep these kind of short. Please let me know if you have any questions about any of these, any new aspects of the knowledge base. And again, I'm thrilled that people are using this to understand the sum lines better. But again, there's a world of information here now for any cell line that you've probably worked with. And this information is hard to come by using DepMap Portal or Cellosaurus. You've really got to dig, and you almost really have to know what you're looking for. So the idea behind these tools is to make it very easy, just doing mouse clicks, to really take a deep dive into the genomics of all of these breast cancer cell lines. Okay, that's it for this video. Please, again, let me know if you have any questions, and I'd be delighted to chat with anybody, or either by email or by Zoom, and make this resource as useful to you as possible. Okay, thanks again, and I'll see you next time. Bye for now.